Hello everyone, my name is Andrew and today I will show you how to use our new aggregator function approx percentile. First of all, let's connect to our cluster. I have a prepared database called cluster monitoring that contains a cluster management table. Here how it looks like. So this table contains a host name, process name, when it was started, how much process CPU it used, how much thread user time it used, what was the connection delay. Let's see how much data do we have in this table. So as you can see, this table contains 7.5 million of rows. Not big, but for our example it's pretty good. Let's get a sample of data. Okay, imagine that you are developing a monitoring system for your cluster, which should alert you whenever things go bad on your cluster. Let's say that process works badly if it's delaying more than 95% of other process delays you have. Let's get these boundaries. We want to see the 95th percentile of the connection delay column for each host and process. Previously, you should type the next query. Now let's do the same thing with approx percentile. Wow, much faster, right? So what's the difference between percentile count and approx percentile? SingleStore uses the remarkable t-digest algorithm to calculate approx percentiles. A t-digest is generated by clustering real-valued samples and retaining the mean and number of samples for each cluster, also known as a centroid. T-digest keeps a buffer of incoming samples. When buffer fills, the contents are sorted and merged with the centroids computed from previous samples. The t-digest implementation in approx percentile sorts only a small amount of data at a given time, whereas analogous percentile function like percentile count order all data over all partitions, which leads to slower performance overall. Let's make our query more complex and add the same boundary for thread user time, same as we did for connection delay. And now let's execute the same thing with approx percentile. Wow, you can see that we executed only in 0.68 seconds, while it took us 7 and 8 seconds to execute it with percentile count. Now let's make our table a little bit bigger, duplicating the rows. So currently our table is only 7.5 million rows. Now it will become 15 million rows, 30 million rows. So finally it's 60 million rows. It contains 60 million rows. Let's run the same queries on the bigger table and see how much time it will take us to run them now on 60 million rows table. Wow, it took us 30 seconds. Meanwhile, approx percentile did it in 3.5 seconds. Now let's run the complex query with 2 boundaries. Wow, it took us 1 minute and 8 seconds to execute this. Let's try approx percentile. Oh, it only takes us 5 seconds. So as you can see, approx percentile is faster in merely 10x times. So now you see the power of our new aggregator approx percentile. Thank you.